Welcome to Monticello Podcasts, a series of audio presentations about Monticello, its history, and the work of the Thomas Jefferson Foundation, which has owned and operated Monticello since 1923. Recently, I spoke with stonemason Henry Cersley, a veteran of many projects at Monticello, about the north section of the all-weather Passageway, which has been the focus of a major restoration project since November 2004. If you're listening to this in front of a computer, you can click on the image above the link to this file to serve as a reference. If you brought this file to Monticello on a portable device, there are a couple of places where you can see the work being done, but you may want to orient yourself first by standing under the corner of the north terrace with the privy to your left and the ice house over to your right, so that you're looking down the all-weather passageway back toward the basement of the house. This is where Henry and I were standing when I asked him to explain a bit about what's been going on here.
Basically, the walls had both walls, as you're looking at it from here, the left one and the right one, due to soil pressures, hydraulic pressures, and I guess tree roots didn't help it any. Those walls had bowed inward a little bit since Jefferson originally constructed them. Had an engineer come up here a couple of years ago and decided that the wall on the right was reaching the point of failure. So they put some steel bracing in here just to temporarily stabilize it while a plan was formulated to what to do to correct it. A bunch of ideas were tossed out as far as what was the best way to approach it, and ultimately we settled on a plan of excavating behind it to relieve the soil pressures, then installing a series of jacks in here, and they're mechanical jacks like those under a scaffold rather than a hydraulic or anything like that, but basically a series of mechanical jacks to gradually apply pressure to the wall to straighten it.
And those are the things that look like braces right here.
Right. We've got, if you look in there, there's a lower set, a middle set, and the upper set is angled back a little bit to the left because we're pushing against the left wall. That's sort of our anchor to push the wall on the right. The reason the top ones are angled is to make sure that the point at which we're applying the pressure is below the grade on the exterior. Otherwise, we would simply put all the jacks horizontally, but the top ones are angled down so we can make sure there's something behind the wall on the left that we're pushing off of.
How far did the wall on the right bulge?
It varied from end to end, but the worst place was right in the center of it, about halfway up the passage, and probably 4 to 5 inches at the very worst.
4 to 5 inches?
4 to 5 inches. Most of it was a little less than that, but that was the very worst point.
Okay. It's pretty noticeable.
It is. On the left right here, see this piece of steel is pretty straight.
Right, and this is sort of outside of the passage.
Right.
The bracing that we're looking at just a few feet away from us.
Right. This piece of steel is absolutely vertical. You can see where the wall is deflected behind it. The wall on the right up and that was pretty much a mirror image of it.
That looks like more than 4 inches, though.
This particular one is.
That looks like
this is
9 inches or something.
Yeah, this is a pretty bad spot on the wall that faces the east lawn. The other one wasn't quite as bad as this, but for the most part, you could say it's pretty much a mirror image of it.
Okay. And the other one was, you said it was only 4 inches, and this one seems about 9 inches. The right one was the one that was in danger of collapsing.
It had a point about halfway up that had an extreme bulge in it.
Okay.
One of the things that surprised us once we got into chipping some of the mortar out is that wall showed several generations of repairs to it already. So it apparently has been a recurring problem. That mortar gave us a little difficulty in getting it out because it was a cement-based mortar rather than a softer mortar like Jefferson used. But in any case, for some reason or another, the wall on the right has had recurring problems, and the one on the left appears to be pretty much Jefferson period.
Okay, you mentioned the cement-based mortar as opposed to the softer mortar. What are the differences between those?
Basically, up until cement started being used in mortars, they were lime-based. It was basically lime and sand, and usually there was some type of additive in there to help it set a little quicker. In Jefferson's case here, it looks like they put brick dust in it. And that's Roman technology. It's not something they came up with, or the Jefferson's masons came up with. But in any case, it makes the mortar set a little quicker and a little harder. The Jefferson mortar, for the most part, is pretty good here. Portland cements were developed in Europe in the mid-1800s or so, and they found their way here late 1800s, 1900s, somewhere around there. And the repairs that were evident on this wall on the right were a cement-based mortar. So we can't date it exactly as far as when those repairs took place. But the repairs were made with a cement-based mortar. It's harder, it's less resilient, so it will tend to fracture rather than moving a little bit, as old structures tend to do.
And the older mortar, being softer, is more pliable. It will move easily.
It will tolerate movement a little better. I mean, all structures move a little bit, and you generally don't think of a mortar as being elastic, but it has elasticity is a good word for it. It has a little elasticity to it where it will tolerate some movement due to stresses, whereas a cement-based mortar will tolerate none. It simply will fracture and get cracks in it.
How many jacks are there? They look like 30 or 20 or maybe more.
We have got 60 that are in pretty much a horizontal position on the inside,
okay,
and 60 on the outside directly opposed to them,
okay,
so that we can control the movement of the wall. And then there are some vertical ones in there that we used basically to jack up the right side of the terrace just a little bit to free the wall up so we could move it.
Okay. Now we're looking at the inside of the passageway, and you said that on the outside, so the side on the west lawn has jacks as well, and that's been excavated to allow the wall to move and also to relieve the pressure from the soil.
That's right. Reason for jacks on the exterior as well as the interior, we were fairly confident we could push the wall back to a reasonably vertical configuration there, but we wanted jacks on the outside so that we could control the movement of it, so that the thing wouldn't take off and go too far as we moved it.
So how far have you moved the wall now?
We've got it where it's pretty plumb. It's pretty close to where we want it, and it'll be probably a couple of series of just trial and error here. Generally speaking, if you push a wall back like that, you have to take it a little past the point of where you want it to stay. It will slump back a little bit as we release the pressure on the jacks. So we've taken it from being absolutely vertical. We've probably got it an average of 3/8 of an inch past vertical, and when we release the pressure on the jacks, I expect it to come back a little bit.
So describe the process to me when you're how do you move the jacks?
They're simply screw jacks that normally go under a scaffold. You just turn the handle on them, and it's basically just a long screw there. But it rather than trying to take any one portion of the wall all at one time, we simply would start at one end and work our way through, and turn each jack to where it compressed the wall maybe 1/8 to 1/4 of an inch at a time. Do the whole series of them so that we wouldn't fracture the wall any more than necessary in one spot. We just sort of put a gradual pressure on the whole thing and sit it up.
And as one person is screwing the wall out, someone's on the other side releasing the jacks on the other side a little bit.
That's right. We numbered the jacks so we wouldn't get confused as far as which ones we were tightening and loosening. And we can hear each other through there, but one person will be on the outside. For instance, if it's jack number 40, I'll just tell him out there to loosen that jack a little bit, and I'll tighten the corresponding jack on the inside.
Okay, so now that you've got it pretty much plumb, what's next?
As I said, we'll release the pressure on the jacks on both sides and see what the wall does. If it stays where it is now or comes back a little bit like I expect it to, it will depend on how much it comes back. So there may be a couple of series of taking the wall over a little farther and then releasing it until we get it to where it finds a happy spot and sits where we want it to. Once it does that, we will start taking the panels of boards that we've put in there to sort of basically so we can apply an even pressure on the wall. We will start taking panels off and repointing the cracks that I'm sure have appeared in the wall from the straightening process. Basically, we'll just pack mortar in those to keep the wall where it is. And we'll start at one end and simply work our way back up through the passage and remove all this stuff.
After that?
There's a secondary wall that has to be constructed on the outside. Mm-hmm. The engineer specified some details on the secondary wall that will support it will relieve this wall of the soil pressures and drainage pressures. So the only thing this wall will have to do once we finish the project will be to support itself and the terrace above.
After we get this wall done, then we have to do the outer wall on the eastern side? Is that right?
That's right. There'll be an excavation out there that I gather will start this fall. Archaeology will look at it. A team will come in and excavate it, and then we'll basically just repeat the process on the other wall.
And so we think to be done sometime around 2006?
We should be.
Okay.
There's some unknowns that we've been dealing with that we take our best guess as far as how long it'll take, but you're right on that.
Okay. Well, Henry, thank you very much.
You're welcome.